This is a very important question that we are going to understand in this video. So the problem statement is vertical order traversal. So this is a problem categorized as hard in the LeetCode. So first of all, let us understand the problem statement first, then we will dive into the understanding of the code. So yeah, first they are giving a tree and they are passing the root. So 3, 9, 20, 15, 17, this is the tree. So what we need to do is, as you can see, they are giving the root as 0 0, which is row column. And if you move to the left, you are going to increase the row and you are going to decrease the column in this fashion, which is 1 minus 1. So actually we are going to start print from this. Next here that it is 0, it is also 0 in the same level, then we need to return here like this. Now we have the 1 here, so we need to return, and we have 7 which is only 2, so we need to return here. So now we need to understand that in detail. So let us understand that what is level order traversal. Let's say you have the tree in this fashion. Okay, so you have these nodes. Let's say this is 15 and let's say this is 7. Okay, so the vertical order traversal is nothing but first you need to go in this way, next this one, next this, next. If you see, this is row as 0 and column as 0, and next if you consider, this is first level, this is second, this is third. So here the row is here row is 0, here row is equals to 1, here row is equals to 2, but here column is 0, so here we are getting that 1, because row is 1. Column is, as you are going the left side, you are going to have minus 1 here, and you are going the downwards, the row is 1, column is plus 1, because you are going rightward here. So if you see here again, so this is in the same level. Okay, same level. So for this node the row is 2 and the column is, you can see, it is 0. So for this node the row is 2 and the column is 2. So in this fashion you need to identify, so in this fashion you need to draw the diagram first. So after drawing the diagram, you need to understand two things, how you can solve this problem. So for this you need to know two things. That first thing, that you need to require a queue, and the second thing, you need to require a map. These are the two necessary things that you need to have to solve this particular problem. So let us understand how you can solve this problem with the help of the queue, and let's say with the help of map and queue, how you can solve this problem. So let's say you have 10 here and you have 20. How you can solve this problem? This is from left, this is this side, this is this side. Okay, so how you can solve this? First of all, I will maintain a queue. So here the queue data structure will be somewhat big. So let's assume this is the queue. Okay, this is front, and let's say somewhere here is the back, or front back, or you can call it as rear. So inside this queue, I will call it as queue. Okay, inside this queue I will be going to store the tree node, and I will be also going to store the row and column, and like this only I will be going to store here tree node, row and column. So in this similar fashion I will be going to store in each box. I will be requiring three things. First of all, what is the use of queue? So if you understand what is the use of queue in this example, so that you can understand. So the queue's job is, it helps us to visit all nodes and carry their row and column. So basically, what is the role of queue? So queue is nothing but this is the way how you store the queue. So it helps us to visit all the nodes and carry their row and column. So this is the we need to visit the queue, which is nothing but BFS data structure that we are going to follow in this video. Okay, this is the queue. I hope you got the queue. What is the main purpose of the queue? It is for visiting purpose. For visiting each and every node, we are going to use the queue. Now what is the main purpose of the map and why we are using the map? So map is nothing but that the data structure which you will be going to store with the help of the key value pairs. Now what is the key and what is the value? That let's say this is the key and this is the value. For example, what is this data structure and what we are storing in this? So key is nothing but we are storing column, and in the value that we are going to store, which is row, each row, and we are going to store the node value also. Okay, this is the way. So next one is row and node value. So this is the way how you store all the things. So this is the column, this is the row, like this is the row and the node value. So this is the map. Okay, I hope you got that, because we are storing two values here. As you can see, we are storing the two values, and in the queue structure we are storing three values. So now I will show you the syntax, how to declare this queue and how to declare this map also as well, so that you don't have any confusion. So first of all, I will be going to show what is the syntax of the map. As you are storing the key as one value and the value as two things, so you will be going to require the map data structure in this fashion. So I will be going to, I am writing in the C++. Okay, so first of all, the key is integer, because this column is integer, and we are going to say integer, and next we are going to have a vector pair, because row and the value is a pair. So vector, so this is the syntax how you declare the map, and this is the syntax how you declare a queue. So basically the key is integer here, and the value is a vector of key value pairs. And queue means here, let's say when I show you the example, so that you can understand how this map is stored. And in the queue you are going to store a pair of the tree node. It is a pair of tree node, and you are going to store a pair which is the integer and integer. Here is nothing but row and column. Now let us understand how the flow happens. So let us understand the steps first, so that you can understand clearly. So these are the steps that you need to follow to get the output. So first of all, we need to going to start from this root node. Okay, we need to going to start from this root node. Next, queue helps us to reach each and every node. So first of all, what we are going to do is, as this is the first node, so I will be going to make it which is 0 or comma 0. Let's say this is the root. Okay, the tree node is which is root. So we can call as root comma 0 comma 0. This is our first call. Okay, so means we can queue dot push. So the first value that we are going to push into the queue is this value. Okay, into the queue we are going to push first value is this value. This is root 0 0. Okay, when you pop this one, you are going to place this 10 value, means this value which is y 1 comma and 1 comma minus 1. Okay, so as you know simply how you will do the normal thing, when you are popping this one, you are going to place this one and this one. So again you are going to place 1 and plus 1. Why? Because this is 1 comma 1. So in this fashion you are going to populate this complete queue. So that only I have written over here. So queue helps us to reach and every node. So when you pop this one, you are going to place this and this. So when you pop this, you are going to place and this into the queue, and you are going to populate this with each and every node value, row and column. I hope you got this. So after after getting the queue populated, now along with each node carry its row and column. Yeah, we have understood how to carry the row and column. Put the node into map using the column number. Okay, we are going to place, means we are going to populate the map with the help of this column number. Means if I show you the column number, then you can understand. Okay, so this is the first one. Okay, this is the first one, which is -2 column, and if you see this is -1 -2. Okay, and it is again coming to 0, and if you see this is +1 and this is +2, and again it is coming to 0. So basically this node coming to in a single position. Okay, basically we can simply say these three are in the same row. This also means I can say I can draw in this fashion after this and finally this. So for the column 2 -2, I am having the 50 value, which is means we are going to store the this is row value which is 2, row value means 1, so 0 1 2. Okay, so we are going to store the -2 column as 2 comma, which is nothing but this. So if you see the row which is 2, so this is the column. So this is the column corresponding to, we need to place the row and the node value which is 50. Okay, now column -1, now column 0. Okay, after column 0 we have column 1, column 2. Okay, only we have column -2, column -1, column 0, column 1, column 2. Only these are the columns that we have. So the first of all we need to see the column -2 having only one value. Now column -1 we have two values, which is nothing but here we are having 10 and 50. So we are going to place 10. Okay, we are going to place 10 and 50. Now column 0 we have three values, 20, 60. So we can place 20, we can place 60, and we can place 5. Now column 1 we have only one value, which is 35. You can see over here. So I can place 1 comma 35, and finally column 2 we can place, which is as 2 comma 20. So this is the way how your map will be populated at finally. Okay, so after this, in this fashion you can observe clearly If you understand now we are going to understand. So now you can clearly see the code over here. So now clearly you can see over here we have declared a map and we have declared a queue. I have already said the map data structure and I have already discussed the queue data structure. That's why we are taking in this fashion. Okay, you can clearly see the map is a integer and it is a pair, and a queue is a pair of the tree node and the values of that, which is row and column. As you can see here, the first value that we are passing, which is the root value, and 0, 0, which I have indicated node, row and column over here. Now, so from here to here we are going to populate the queue. Okay, not like in the normal simple BFS code. So we are populating the queue and we are checking while the queue is not empty, because first we have populated with the root value. Okay, now auto. So this is the syntax. Now I will explain what is the syntax. Okay, now we are declaring like auto node comma position, like POS is equals to q dot friend. Okay, so what is this auto? So auto is a new syntax that was introduced in C++ 17, and this syntax we also known that is called as structured binding. Okay, you will also understand why this is known as structured binding. I will explain in a while. So I will explain what is this auto, this position. Okay, now what we need to understand is, let's say what is this auto. Let's say I have declared int x is equals to 5. Okay, now if I say auto y is equals to x, then by default auto means automatically this line will be converted as int y is equals to x. Okay, the data type of y will be converted as the data type of the x. So this is the meaning of this auto. So instead of writing the long codes, you can simply mention auto. So I will show you. So how this line will be evaluated if you write auto in front of it. So basically the queue, because this we are having the queue here. So queue is a pair, and inside this pair what we are having the tree node. Okay, we are having the tree node, and comma we are having again a pair. You can see over here, you can see we have a root, this is the tree node, and we have a pair again here. So this is the row and this is the column, this is a pair. Okay, our pair it is an integer and integer. So here this tree node will be called as this node. Okay, node will be called as the tree node. The data type of node will be considered as the tree node. Okay, and the data type of this position will be considered as this pair. So this position is considered as a data type of pair and integer of integer. Okay, if you want to separately you want this row and column with the help of this access of this POS. So you can simply say POS dot first. So this will return you the row, and if you say POS dot second, and this will return you column, because it is a pair. You can also observe clearly over here, I am accessing the row with the help of POS dot first. I am accessing the column with the help of the POS dot second, and finally I am populating the map with the help of this line. Okay, so this will be populated the map in this fashion. So in this fashion you are going to populate this, you are going to push the row value and the node value in the column of this map. Okay, after that, so if you are moving to the node left, so you can simply increase the row and decrease the column if you are moving to the left side, and if you are moving to the right word, you can simply increase the row and increase the column. And up to here you understood how to populate the queue. So after populating the queue, you can take the answer which is of type vector of vector. Okay, we need to return the type return the answer as vector of vector. So why we need to return the answer in the vector of vector form? Because the final answer will be looking like, let's say you have got column -1 as 1, 9, 2, 15, and let's say you column 1 you got 1, 20, and finally column 2 you have got 2, 7, and final answer will be sorted off, 3, 2, 15, 20, 17. So this will be 9 and this will be 3, 15, which will be sorted order. So that's the reason that you are going to sort here. I will explain why you are sorting here, because this is the reason. Because in a single column you are having two values, so these two values you need to sort. So after that you need to have 20 and you need to have the 7. So this is the vector of vector form that you need to return the answer. Okay, so I am declaring the answer and I am having the for loop. Okay, in the for loop again I am calling this auto. So in the map I am calling the key as column, I am calling the value as nodes. Okay, I am sorting the nodes over here. Okay, means I am sorting this 3 and 15. So after that I am declaring a temp, because this is a temp this is a temp, this is a temp, this is a temp. Okay, I am populating the temp with the help of these lines. I am populating the temp with the help of these lines. How? Because I am getting the row, I am getting the value from these nodes. I am getting the row, I am getting the value, I am getting the row, I am getting the value from the what? From the map dot nodes. Okay, the second value, and we are populating the temp. Okay, and finally we are pushing that all the temp values in the answer, and finally we are returning the answer. I hope this makes some sense now. If I run this, you can see this will be running absolutely fine. And if I submit this, so you can see this will be submitting successfully, I think. So it's compiling now. You can see all the test cases has been 34 test cases has been successfully passed. So finally, this is the way how you write the code, simple code in the form of this map and queue data structure. Now, so we need to understand the time and space complexity for this code. So let us understand what is the time and space complexity. So if I talk about the time complexity, the time complexity would be n log n. It will be slightly larger than n. And if I talk about the space complexity, it will be order of n, which will be the data structure which is q. And if you also want to add in the map, so you can also add order of n, which is for the map, which is also considered. So ultimately order of n plus order of n, which is nothing but 2 times order of n. So you can simply ignore this, which is order of n finally. Time complexity is this. I hope you understood this video. Thanks for watching this video. Please do like, share and subscribe for this video.